Hello, honors algebra students. Hello, honors algebra students. Hello. I'm just messing with you. It's not really messing up. Haha, hope you're still listening. Mr. Laurence here with his great sense of humor. And we're going to do a quick sequences review. Now remember that when the first differences are constant, what kind of function is it? What's that, Sean? Yes, it is linear. Nick, give me an example of a linear function. Say it real loud, Nick, so everybody can hear you. F of x equals 2x minus 1. Yes, good job, Nick. That is a linear function. Now, remember, it's not just 2x minus 1. We need the f of x part, right? Okay, let me see. Let me call on Boyana. Boyana, when the second differences are the same, what kind of function do we have? Well, Mr. Lawrence, we have a quadratic. Wow, Boyana, you sound a little sick, but that's okay. You're absolutely right. And who can give us, Haley can give us an example of a quadratic function. F of x equals x squared plus 1. Great job, Haley. Love working with you. All right, third differences are constant. Let's go with Mr. Emilian. No, I can't say that. He won't say anything. No, he does. Emilian, you're great. Just say it nice and loud. Okay, Mr. Lawrence, it's cubic. Very good, Emilian. When the third differences are constant, it's cubic. And then let me see here. Mike will tell us an example of a cubic function. F of x equals x cubed. Yeah, that is a cubic function. Yeah, sure it is. Absolutely. You don't have to have anything added or subtracted to it. That is a good example. All right, finally, when the fourth differences are the same, you don't see as many of those, but when the fourth differences are the same, we have, let me see, who haven't I talked to in a while? Colton, are you done doing your jumping jacks and push-ups? Okay, then you can answer for us. Oh, no, that's not Colton. My mistake. It's Colin, excuse me, Peretti. All right, so that would be quartic, right, Colin? Yes, quartic. Sorry about that, Colton. You haven't had to do push-ups in a long time. All right, quartic. So Colton, you can give us an example of a quartic function. And let's see here. F of x equals x to the fourth plus 2. Absolutely, that's a quartic function. Now, I'm really bad at impersonations, as you can tell. Please don't take offense. I mean nothing by it other than entertaining myself while I make this video, and hopefully it's a little more entertaining for you. When the differences are multiples of each other, you know, maybe they're doubling every time or tripling every time, we don't get a linear, quadratic, cubic, or quartic function. That's what you discovered trying to solve the Tower of Hanoi. So when the differences are multiples, that's when we get, let me see, let me call in one more person here. Hold on. We got a new student in the classroom. His name is Kermit. Kermit, when the differences are multiples of each other, what kind of function? Hi-ho, Kermit the Frog here, and Mr. Lawrence, that would be an exponential function. Yeah, exponential, exactly. Oh my goodness, good job. I just don't know how to spell it, Kermit. I loved your answer. Let's see, exponential. And Kermit, could you give us an example of a function that would be exponential? Sure, Mr. Lawrence. It would be f of x equals 2 to the power x minus 2. Very good, Kermit. Well done. For a new student, you are just amazing me. So, these differences can tell us what kind of function the sequence is generating. It's important to know this. You'll want to have this memorized. It's not difficult to memorize, but you might, you know, make flashcards or whatever you need to do. If you've already got it, you're good. No problem. Oh, that's not an exponential. Excuse me. That's supposed to say example. There we go. Those are example functions. Those aren't the only functions. Those are just examples. There's only an infinite number of possibilities that you could have listed. All right, so here's what we're going to do. I'm going to give you a sequence of numbers. I want you to pause the video, try to find out what type of function it is, and, excuse me, write the function, okay? If you're still watching, you should have already had your answer, so I'm going to do it here. I'll demonstrate it for you. Okay. And so I need x and f of x, right? Okay, and so 1, 2, 3, 4, and 5. and that will be n. Okay, getting rid of those dots there in my way. I'm going to go looking for differences. So the first thing I'm going to do is going to get plus 7, plus 19, plus 37, and plus 61. I already know, just by doing this so many times, I know that pattern of numbers. I know this is going to be a cubic, all right? But let's go down. For those of you that don't know yet, it's okay. You're new to this. You may not realize that. 24. And then the third differences get me plus 6 and plus 6. And remember, there's not just 2 third differences. The only reason we have 2 third differences and 3 second differences and 4 first differences is we don't have enough information. If this sequence went on and on and on, we would have more numbers on the first difference line, more numbers on the second difference line, third difference line, etc. So I was right. It goes down to the third level, third differences, and so we get an n cubed. And now I'll do my comparison line, and I'll cube the numbers. I'll cube 1, I'll cube 2, I'll cube 3, I'll cube 4, and I'll cube 5. And then I will compare them to the original black numbers. And it looks like my blue numbers are all 3 less than my black numbers. So the nth term will be n cubed plus 3. Therefore, my function is cubic. It is a cubic function. And it would look like f of x equals x cubed plus 3. And there you go. All right, I don't know about you, but I love doing these things. I feel so smart when I can figure them out. And actually, Miss Clark, she was having a little trouble with this, the way I teach this. She just wasn't quite clicking with her. So she went and did some research and kind of worked it on her own. And she discovered something really cool that I didn't know about. And I'm hoping I have time to show you. We're getting close to this park, and I got to make sure I get through certain things. But it's really a cool thing that she discovered. It would help you on a problem, say like if it was, say like 4n squared plus 2n minus 1. We haven't done anything that complicated. She knows how to do that now. She showed me. It's really neat. So anyway, I hope to get a chance to show you that. All right, let's do another sequence. Go ahead, pause the video. This one looks kind of strange because it kind of repeats. -2, 0, 4, 10. Yeah. Go ahead and pause the video, and when you're ready to see my solution, hopefully we will agree. All right, so I'm going to put my little table in here. And let's see. I got x. I've got f of x. And I got 1, 2, 3, 4, 5. And I will do my nth term, right? So I'm going to look for the first differences. Well, this is plus 0, right? And this is plus 2, and plus 4, and plus 6. Oh, that looks familiar. It's strange that I had plus 0, but it seems to fit. And this would be what? Plus 2, plus 2, plus 2. Second differences are all the same. This must be quadratic. This is a quadratic function. Quadratic. All right, so it's n squared, and I'm going to square 1, 2, 3, 4, and 5. So 1, 4, 9, 16, 25. All right, now I'm going to see what the difference is. Well, I'd have to subtract 3 there. Here I'd have to subtract 6. Here I'd have to subtract 9. Here I'd have to subtract 12. Here I would have to subtract 15. That's a little bit weird. I have to subtract 3, 6, 9, 12, 15. What am I going to do on the nth one? Hey, wait a minute. Couldn't I think of subtracting 3 as minus 3 times 1? Because it's the first one. And then this one, instead of minus 6, I could think of it as minus 3 times 2. And then the third one is minus 9, so that would be minus 3 times 3. And the fourth one would be minus 3 times 4. And the fifth one would be minus 3 times 5. Right? And so that would be minus 3, whatever the number is. Well, if I'm on the nth one, that would be n squared minus 3n. Or just better yet, 3n. So it's quadratic, and my function is going to be f of x equals x squared minus 3x. And there you go. I like these problems. I feel so smart when I can do them. Okay. Let's check this one out here. Same thing. Pause the video. When you're ready to see my solution, you can unpause. Okay, I'm setting up my table here. And maybe I'll just do it this way. I'll just clone him so I don't have to keep redrawing. I guess that's working out okay. And then getting rid of those dots just because they're in my way. I need a horizontal line there. I got x. I got f of x. I got 1, 2, 3, 4, 5. I got n. So let's go finding our differences here. I've got a 6. I've got an 18. 54, right? Okay. And 78, well, it's going to end in 2, and then 13 be 23 be 16, 162. I'm not really seeing much on this one. It's really strange. I do notice, though, that this is times 3. That's got me thinking. I'm wondering if 18 times 3 is 54, or 54 times 3 is 162. Oh, but maybe I'll go down to the second differences. Let's see here. Plus 12. Let's see, that would be plus 36, I think. And, oh, hey, there's that times 3 again. 12 times 3 is 36, isn't it? All right. And then here, 108, I think. Yeah, 108. Oh, yeah, hey, check this out. Check this out. 84 times 3 is 162. 36 times 3 is 108. The reason I pretended like to not know was I wanted to show you that the multiple, the times 3, the number being tripled, the difference being tripled, will show up on any line. It'll show up on any line. If I come down to this next line here, I'm going to get a difference of 24. Okay, here I'm going to get a difference of 72. What do you think 24 times 3 is? 72. It doesn't matter when you discover it. If you see right away that 6 times 3 is 18, and then you test it here and here, then you know, hey, I've got it tripling every time. If you don't see it on the first line, you might see it on the second, possibly the third. If you see it on the third, then test it up here. Okay? So it's times 3 all the way. So when it's multiplied every single time, it's exponential. Okay? And the number that I'm multiplying by is my base. That's what gave some of you a hard time in the Tower of Hanoi. If it had said times 7 every time, I'd have a 7 to the power n. Now, I'm going to do my comparison line here. And I'm going to raise 3 to the first power and get 3, and 3 to the second, which is 9, and 3 to the third, and then 3 to the fourth, which is 81, and 3 to the fifth, which would be 243. And then I'm going to compare up. Oh, look at that. It's 3 too many, 3 too many, 3 too many, 3 too many, 3 too many. So the nth term must be 3 to the power n minus 3, because each one of those is 3 too high. So it's an exponential function. That's the type of function it is, exponential. And it's f of x equals 3 to the power x minus 3. There's your function itself. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.